Hello everyone, I'm Saptarshi Mukherjee. I'm a software engineer 3 at Google and a competitive programmer. So, in this playlist, we are discussing the problems that appeared in the Codeforces round 922, and this video specifically focuses on the problem number B, which is minimize inversions. So, let's get started. Before that, um, please like, share, subscribe if you like the videos, and please do share with people who will find the video informative. This is uh, basically for helping people to find the right intuitions of solving these problems and becoming better and better at problem solving. So yeah, so let's get started. Minimize inversions. Before we get started, inversion, a very common term in our programming classes, programming exercises. And this is what an inversion means. It emanates from all our sorting practices. So, an inversion in a permutation is a pair of indices such that I is less than j and pi is greater than pj. So, let's take an example. Let's say we have something like 3, 1, 6, 4, 5, 2. This is a permutation of the numbers from 1 to 6, but it is not sorted. What is an inversion? This is an inversion, that 3 is coming before 1. 6 is coming before 2. This is an inversion. 6 is coming before 4. 6 is coming before 5. This is an inversion. 3 coming before 6 is not an inversion because 3 should come before 6. So, in simple language, wherever a greater number appears before a smaller number, that is an inversion. It is given that it is a permutation. In the question, it is given that it is a permutation of numbers from 1 to n, which means there are no equal numbers in the array. They are all distinct numbers, and our task is about these inversions. So, as you might have guessed, I'm not completing it, but 4 greater than 2, these are all inversions. I think I have marked all of them. 3 greater than 2, yes, this is also an inversion. Right. So, that being about inversions, many of you might be aware of sorting techniques, um, where we somewhere deal with inversions or count of inversions, etc. Bubble sort is one sort where we rectify one inversion at a time. So we have an unsorted array. In bubble sort, we rectify one inversion at a time. In case of selection sort or some other algorithms, it's slightly different. In case of merge sort, again, it follows a very different strategy of divide and conquer. So inversions, how many times we are inverting, etc. Somewhere, if we look deeply into the working of a sorting algorithm, we can categorize sorting algorithms based on how they are inverting, what is their exact strategy, etc. Anyway, coming back to the question. The question says that we need to minimize the total number of inversions in two permutations. So there are two permutations given to us. One is permutation A, A1 to AN, and another permutation B. Both have the same number of elements, two given permutations of length n. And this is what we can do. We can choose two indices I and j, and we have to swap those indices or the values at those indices in both A and B. So two permutations are given. Um, let's say this is one permutation and we have another permutation, or let's do it separately. 2 1 6 4 3 5 and 4 2 3 1 6 5. So now you can see that 2 is greater than 1. So you can say, hey, if 2 is greater than 1, I will swap this. If you swap these two positions, that means on the other array also you have to swap them. So this will get swapped with this. So 1 will get swapped with 4 and 2 will get swapped with 1. In this way you can do as many times as you want, you can do this. That is given in the question. So you can choose two positions and you have to swap those elements at both A and B. And as a result of all these operations, you can do as many times as you want. As a result of these operations, you have to minimize the total number of inversions in both permutations. So at the end, your permutation A will have some X inversions, permutation B may have some Y inversions. Your task is that X plus Y should be minimum. possible. It's not necessary for one to be as minimum as possible. The other one can, the some should be as minimum as possible, and there can be multiple answers possible. So you have to do this. If you look at the example 312, 312, they are equal. So in this case, swapping was very easy. So you can say that 1 got swapped with this 2. So 2 came before, 1 went later, and then 1 got swapped with this 3. Or you can say 3 and 2 first got swapped. 3 went to the end, 2 came to the beginning, and then 2 and 1 got swapped. So in that way, over here, both of them got sorted because they had the same elements. I mean, A and B were the same. So it was easy to sort them. But in the other case, if you look at this one, 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Over here, if you see, this is the array that has formed. They have permuted something. So if you see over here, uh, 3, 3, 3, 3 has come over here, 5, 1 has come over here, 1, 5 has come over here. A lot of swaps has happened. And eventually, it is claimed that the minimum possible number of inversions is 10. So you can have other answers as well for this particular pair of permutations, but the answer, the minimum number of inversions cannot be better than 10. So you have to give one such answer such that you have the best number of inversions. Okay, so we know what are inversions, we know what the question is. Now let us see how we can solve them. First of all, in this kind of problems, the most general way to avoid getting distracted, avoid going in the wrong path is, don't get confused with so many indices together. Don't think that, okay, I have AI, BI, AI, AJ, AK, AL, all of them together. Don't need to think. If you have some AI and AJ, think pairwise because it's the inversion that matters. An inversion is defined on the basis of a pair. Don't think that by moving A and J here and there, by shifting them across them, so basically by swapping them, you will make others happy, like AK sitting over here and others over here, others over here. Don't think like that. The reason being, you can always swap AI with AK. So if you have to worry about AK, swap with AK. Don't worry about all those things. And that same strategy is applied for bubble sort, for many other sorting techniques. So basically, do what is there in front of you. That is often the easiest strategy. So let us follow that strategy for the rest of this solving exercise. So what we will do is, we will focus on a pair. Let's say this pair. AI, AJ, BI, BJ. Now, for this pair, should I swap or should I not swap? I and J, I is less than J, that is the only thing I know. They may or may not be adjacent, I don't care. I don't care about the others. I can take other pairs, I can swap them, I can swap any number of pairs. So for the moment, just focus on these two. What is the best I can do? AI less than AJ and BI less than BJ. If both are lesser, that means it is the best thing. But often it is not the best. What are the possibilities? Over here, what are my possibilities? Either I'll have an inversion or I will not have an inversion, yes or no? Right? Over here also the same possibility. Either I'll have an inversion or I will not have an inversion. So either my number of inversions will be 0 or 1, which means that my total number of inversions will be either 0 or 1 or 2 from this particular pair. The number of inversions will either be 0 or 1 or 2. Okay, if it is 0, what does it mean? Can I improve it further? No. 0 means it is already at the best. So there is no way to improve from here. 0 is fine. It is very good at where it is. 1, can I improve it? Possibly, yes. So if it is something like this, 2, okay. I was thinking of the possibility that AI is equal to AJ, but that is not possible. So no, AI is either less than AJ or greater than AJ. 1 basically means that 1 is not possible. That's what turns out, right? So 1 basically means 1 is there is okay, sorry. So 1 basically means that one of them is 1, the other one is 0. It can be this way or that way. This is 0 and this is 1, right? So either this is lesser, this is greater, or the other way around. So in that case, what does it mean? Let's say this is lesser, this is greater. In that case, I'll get 1. I'll get this 0 and this 1. And then the summation will be 1. I have one inversion. What happens in this case? In this case, if I invert them, if I let's say invert them, swap them, invert or swap them, what happens? This becomes an inversion now, AI greater than AJ, and this will cease to be an inversion. This will no longer be an inversion. So one gets corrected, the other gets damaged. Correct or not? Right. So I can't improve this. I can't improve this. For 0, I can say definitely both were 0. So if I swap them, both will become 1. I definitely don't want that. And here also, here 1 will remain 1. So there is no use. If I change the 0th case, it will become 2 definitely. If I change the case where it is 1, it will change to 1. What about the case where it is 2? That means both are 1. What about that case? In that case, I'll get better. The inversion count will reduce to 0, right? So what do I see? I only need to care about those situations. Again, now coming back, I'm worrying about a pair. What is the maximum number of inversions possible for a pair? Maximum number of inversions possible is 2. For AIAJ, BIBJ, it is 2. If it is 1 or 0, I cannot improve it by swapping. For any pair. So it's something like, let's say you have 5 pairs. Again, ultimately the total calculation will boil down to the pairwise thing. So if I consider every pair, AI, BI and AJ, BJ, this is what stands out. If both have an inversion, then only it makes sense to really swap them. Otherwise, I will damage one or the other, or both. So that's what turns out, that okay, I just have to detect this case. How to detect this case? That both are an inversion. I can do a brute force. I can say, hey, do the bubble sort kind of thing. It's just a bit more time complexity. That's it. So let's go back and see the time complexity. Time complexity is, so the sum of n goes up to 2 into 10 to the power 5. N goes up to 2 into 10 to the power 5. So big O n squared definitely can't be our time complexity. Otherwise, we would have compared every pair. What is the other thing we can do? That's what we do in comparator sorting. We say there is one condition based on which you can sort two indices, two different positions. That's what we do with comparator sorting. But when is this true? When both are equal to 1. This is the condition for swapping. I hope you got it. The other two are conditions of no swap. So swap will not give any betterment. Swap doesn't imply any betterment. Okay. So how can we, what condition can we impose such that we can ensure, yeah, this 2 will come out? What condition about I and j if I give? Basically, I can simply, in my comparator, I can say that if AI is greater than greater than AJ and BI is greater than BJ, then swap. This is simply my condition. Swap the positions I and j. This will be the this will be the logic of my comparator. This will be the logic of my comparator. That's it. One another technique. So one thing that I used is that, or that first came to my mind. Let me show how it came to my mind. When I looked at this problem, when I looked at this particular test case, 2, 3, sorry, maybe this one. I saw that AI plus BI for every I gives me 6. 3 plus 3, 6, 2 plus 4, 6, 5 plus 1, 6, 1 plus 5, 6, 4 plus 2, 6. So at every position, AI plus BI gives me 6. Then I thought that, okay, what about this one? Here I see that it is increasing. So 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6. So this gave me the idea that, hey, the sum increases. AI plus BI, the sum is increasing. If the sum increases, does this give me a guarantee? I say yes. If the sum increases, again the same thing. If the sum increases, if I have AI plus BI is less than equal to AJ plus BJ, then this implies that either AI is less than equal to, sorry, is less than AJ, or BI is less than BJ. Either one has to be, or both. And this means I'm falling in this particular range. This is the good range, 0 or 1, which means don't do anything. Which means this becomes my sorting criteria. That, hey, A and B together are getting difficult, so sort by positions. At every position, forget AI and BI. Take AI plus BI. That is what I did. So at every position, just think about AI plus BI. Whichever one has less, keep that before. Whichever one has greater, keep that later. So that is the comparator logic, comparator sort logic. If I take one example, let's say the last example. Here you will get a different answer according to my logic, but that will also give you the correct number of inversions. If I take the top one, it's the same thing. So if I take a different one, maybe a smaller one, 3, 1, 4, 2, 2, 4, 3, 1, something like this. Yeah. So this is 5, this is 5, this is 7, this is 3, the summation. 3 plus 2, 5, 1 plus 4, 5, 4 plus 3, 7, in this way. Now, the simple technique I have figured out is this 3 will come first, then this 5, then this 5, then this 7. So what do I get? 2, 1, and then 3, 2, and then 1, 4, and then 4, 3. Right? If you look at any of these pairs, for example, let's say this one. So there is one inversion over here. But if I swap these two, what will I get? The upper one will become an inversion. So no help from there. So basically, for every pair, I will see maximum one inversion is there. There are not two inversions. So the reverse, the swap will not give us anything better. So we have to reach that state from where no single swap can give us a better answer. We have to reach that step where no single swap can give us a better answer. Similarly, you can say that, hey, if I sort one array, and for sorting one array, whatever swaps I needed to do, I've done that in the second array. Definitely, that is also correct. So if you swap one array, let's say you swap the lower array. So you get 1, 2, 3, 4. Because you brought 1 to the beginning, that means this entire thing will come to the beginning. So this is 2, 1. Then this 2, 3. Then this 3, 4. And then this 4, 1. If you calculate, the number of inversions will be same in both because you are following the same property. You are following the same logic. Here also, you cannot swap any pair and get any advantage. Again, you can swap these two pairs, 3, 2 and 1, 4, because their summation is the same, so they will have the same impact. Nothing changes if you swap them. Yeah. And so, yeah, whatever rule you follow, here you can see this is a different strategy. What did I show over here? This one is sorted. This one is sorted basically means that from any pair in the array B, there will be no inversion. So that is ultimately I'm coming over here. I'm basically trying to eliminate this particular case. So I'm doing something that will help me eliminate this case. What I'm doing is comparator sort. I'll quickly show the code of comparator sort to give you the impression how we can use that technique to solve this kind of problems. Let us take a look at comparator sort. This is my own submission. Very simple code. I formed the two arrays over here. Then I used a custom class where every element contains AIBI. That is, P of I will contain AIBI. That is what this structure looks like. Now I'm going to sort that. How am I going to sort? That is defined in the pair class. In the pair class, I've defined, hey, how does your comparison look like? So if I search by pair, yeah, this is how I've defined it. So I basically said that, hey, you have two elements. Every pair object has two elements. This is the constructor. And then I'm saying, okay, compared to P, so A plus B refers to as if the AIBI, and P dot A plus P dot B. So this will subtract from A plus B, this will subtract P dot A plus P dot B. If the answer is negative, this will treat as if A plus B is, or the ith element is lesser than the jth element. So we shouldn't do a swap. If this answer is positive, that means we should do a swap. The previous element is greater than the next element. So compare to function works in that way. Compared to, it is internally implemented. You just have to write this much, and the rest, the way you're implementing this comparable pair, the rest of the thing it understands itself. When you do arrays.sort, it understands it. This is Java syntax. Similarly, you have in other programming languages as well. So this much you just have to say, okay, compare to using these parameters a and b. A plus b, this means current index a and b, and p dot a plus p dot mean means the other one. So you are comparing current against the other one. If the difference, if this particular answer, if this particular expression's value is negative, then the compiler or the executor that will not swap, and if this is positive, it will swap if you ask it to sort in ascending order. Negative means the ordering is correct, it is in ascending order, the smaller one occurs before, and greater than, basically greater than 0, positive means that it is in descending order, it needs to be swapped to bring it to ascending order. That's it. So I just sorted it in this way, and then I printed it. How did I sort it? I sorted based on the summation. I could have sorted based on just the A. But interesting thing is I'm sorting in this pair object, in this pair array. What happens as a result is when I'm swapping I and J, P of I and P of J get swapped. In P of I, both AI and BI are there. In P of J, both AJ and BJ are there. So when they're getting swapped, I'm not worried about AI and BI getting scattered or getting separated. No, they are both encapsulated in a PI. So that's it. Easy, straightforward coding. One or two times you practice, you will get that. So yeah, this is about problem B. Let me know if you face any doubts, if you have any issues, and stay tuned for the upcoming videos on the next problems. Thank you. Do share with people who might find it informative. Take care. Keep coding. See you in the next videos. Thank you. Bye.